Okay, in this video, we're talking about how we can combine functions using arithmetic ideas. If we have two functions, for example, x squared and sine of x, and we want to know what and we know their Taylor series, and we want to know what their Taylor series, what the product of these functions Taylor series is, we can just multiply. So it's probably best explained through an example. Our goal is to find the Taylor series for x squared sine of x, centered around x equals 0. So we might remember that, well, we've done sine of x before. Sine of x is, what is this? X minus x cubed over 3 factorial plus x to the 5th over 5 factorial, etc. Plus x to the 7th over, minus x to the 7th over 7 factorial. Okay, so this is the first part of the Taylor expansion, or the Taylor series for sine of x, but we want to know what x squared times sine of x is. Well, this is an equation. As long as we do something to both sides, we're allowed to do it to both sides. So in other words, we can multiply both sides by x squared. So multiply the left by an x squared and the right by an x squared, remembering that, well, we want to distribute this through our whole expression. So x squared sine of x can also be written as x cubed minus x to the 5th over 3 factorial plus x to the 7th over 5 factorial, etc. And that's really all there is to it. So I just did an example using multiplication. We could also do one with division. Adding and subtracting, as long as you do the same thing on both sides, totally valid thing to do. Yeah, so that's mostly all there is to it. So I also wanted to mention how this works if we have the direct definition rather than the ellipses, like here are the first 4 terms and it follows a pattern. If we happen to want to work with the direct or the summation notation, so sine of x happens to be -1 to the sum from n equals 0 to infinity of -1 to the n x to the 2n over 2n plus 1 factorial. Okay, and we can check this. We can plug in n equals 0 and make sure that this sounds right. So plug in n equals 0. The first part, it says that it's going to be positive. N equals 0 here, this just makes this, so x to the 0 is 1. That doesn't sound right. I missed a plus 1. There we go. We plug in n equals 0. We get x to the 1, so we get x over n plus 1 factorial, which is 1. So our first term was x. Plug in n equals 1. We should see that our second term is negative x cubed over 3 factorial. So good. This at least agrees with what we wrote before. So again, we don't just want the Taylor series for sine of x. We want the Taylor series for this new function, this f of x, which we can get by multiplying x squared by both sides. And because this x squared doesn't have an n involved with it, we can just move it to the inside, and we're left with the sum of, well, everything stays the same except we're multiplying by an x squared. X to the 2n plus 1 times x squared is x to the 2n plus 1 plus 2, or x to the 2n plus 3, and that ends up being all that really changes. All right, so again, not a lot to it other than just being careful with how we're doing. If we apply something to one side, we should apply it to the other side.